something like a multiplication table. That I wouldn't even write out that way because there's nothing to do, right? I know my multiplication tables, but if this was a problem, your procedure says, I have a 4 and it's supposed to go into this number. Well, just like we did, just like I explained to Natalia about the zeros and the place value, that's what's going on here. You have to start with the left number. Can 4 go into 1, everybody?
No.
No. So I could put a 0 up there, but I don't need to have a 0 in the front of my answer. So I'm going to take 2 place values. How many times does 4 go into 16? 4. So where does the 4 go? Where does the 4 go? Terry? Above the 6. And why did you choose to put it above the 6?
Because it's going into 16 and not the 4.
Okay, the 6 is what made that be collectively 16, right?
Yeah.
Once we know what number that is, then we're gonna say, well, how many times is that actually? And it turns out it's exactly 16, right? So there's nothing to do. Well, let's say it was 17 divided by 4. Now, because of multiplication tables, we know it's not gonna come out to be exactly nice, right? Especially because of the problem we just did. But again, I'm going 4 into 1. No, I can't do that. How many times does 4 go into 17? Well, how many times?
4.
4. And I'm going to take the same advice that Terry just explained, and I'm going to put it above the 7. Well, this time, 4 times 4 we said was 16. So I got to say, okay, it goes in there, just not equally. We're going to have some leftovers. So I think at some point, you guys said, okay, I'm done with that problem. And you just did this, right? That was way long time. That was when you were little. Okay, but the beginning of last year maybe. We're not doing that. We also do not, I'm gonna put this in red so you remember not to do it. You don't take the remainder and just plop it up there. It never existed, don't ever do that. People do that all the time. It's not that way, because that makes no sense. Okay, so instead, I have to know where that decimal goes, right? And we know it goes after the number. We talked about if that was a cash register receipt of $17, it would be 17.00. Why do I put the decimal there? What am I gonna do next? What has to happen next in order for me to keep going, you know? Victor?
You put 1 right next to the decimal.
Did you just tell me to put point four, what, 1?
With the 1.
Oh, you want it here?
Yeah.
What, can you just pull a 1 out of the air and add it to a number? Is 17 the same as 17.1?
No.
What would we be able to put there that's the same as 17? 17 point what?
0.
0. That's why 0 goes there. Because we're not changing the number underneath. But now, we're able to say, well, I'm gonna ignore this decimal for the time being. And I'm gonna keep going for a while. Well, I don't know, I just made this problem up. But what do we do with the 0? Now we're gonna say, I'm not looking at just what's left over as a 1. I'm gonna see if I can keep going and see if it eventually works out. And it will. How many times does 4 go into 10, everybody? 2. And I'm putting that 2 above the 0 because it took 170 in order for me to use that 2. 4 times 2 is 8. And put the 2. What am I gonna do next, Jackson?
You put number 0.
Add another 0. That comes all the way down. It's 20. How many times 4 go into 20, everybody? 5. So the 5 goes there, and thank goodness it came out eventually nice. Now let's talk about that decimal. Where does the decimal go? Cause it certainly isn't 425 times 4 gives you 17. So where does the decimal go? Can I tell you? What do you do with it?
From the floor, from the floor,
Because why?
because
There's a couple reasons you could tell me, well, at least a couple, maybe there's more.
the decimal for 17 is like right under it.
So when you find that decimal, it just zoop, goes right up there, right? It just comes right up. What's another reason that it goes there? Does anybody have another one? Jackson?
Can I use the restroom?
Why is it a good idea to put it there? Did you have another one? Cece?
Cause you line it up,
Cause why?
you line it up.
Well, that's kind of what Natalia explained. But my other reason is, this was 17, right? 4, that's not a 4, times what is 17? That's what we're thinking when we divide. Well, would it make sense that it's 4 when this is rounded, or 42, 425? We're still using the estimating skill. So since about 4 is about 17, that tells me in the end my decimal has to go around where it makes about 4. Natalia?
I have a question. So, whenever you're dividing the decimals, is it always have to be even?
You mean, does it always come out to be 0?
Yeah.
Absolutely not. I think at the problems you'll be getting, they probably do. But if it didn't, 230 divided by 6, this will not come out nice. I don't know if you've seen this before. Let's see what happens. Does 6 go into 2? No. Does 6 go into 23? How many times? 3. Good job. I'm putting that there. And 6 times 3 is 18. 23 minus 18 is 5. Everybody so far so good? I'm using that 0 that's still in the problem. How many times does 6 go into 50? 8. Now, where's the decimal in 230? I don't see one. Where is it? Come on, if it was $230, where would that decimal be? Caden?
Very end.
At the end. So, we are gonna bring it up, because that's where it is. But we're gonna go with what you guys just explained and say, okay, 6 goes into 20 how many times? 3. What happens when the remainder reappears? Do you remember that? Because what I mean by that is 50 minus 48 had a remainder of 2. 20 minus 18 had a remainder of 2. If I keep going, I'm gonna keep getting 2s. Do you remember seeing that at all?
Yes.
I remember seeing it, I just don't remember what to do. Correct? Or do you remember it, Victor? Don't remember? Does anybody remember? Maybe I can give you a clue. This is still gonna be, whoops. It's gonna keep being, we're gonna keep doing this. If we would keep doing this till I had board space, it's gonna keep going on and on and on. Sebastian?
Remainder?
We could put a remainder. It would have been 2, right? You know what's really weird that you would never, I shouldn't say never, never say never. You would rarely see something like this. A decimal with a remainder. That's really weird. You wouldn't see that. Anybody else remember? Cece?
Put the 2 up next to the 3.
No, we would never do that. We don't want to put the remainder up there.
Oh.
This is what I'm looking at right here. Does anybody know a different way to write this? something keeps going over and over and over, Jackson?
ECT.
What? I don't know what you said.
No,
You said no?
no,
What was your first idea?
no.
You said ECT.
What's ECT? Oh, et cetera?
Yeah.
That's ETC,
Oh.
but that's not what it is. That's okay. Did I tell you?
You got it like times 3 times 3?
No, good try. Interested to hear all your ideas. CC, one more?
Pattern
Oh, what?
and a pattern.
It is a pattern, isn't it? The threes keep going. And the question I'm really asking you is, what notation do you use to show that a decimal keeps going? And it is a bar over the number. Have you ever remember seeing that before? Okay. This is a repeating bar. Whatever is under that bar keeps the pattern going, like Cece said. I'm gonna write out a bunch of stuff for you in a minute, okay? That'll help you follow this. But that's how we would write this number, because this notation, it tells you a finite means it ends, a finite way to write something that's infinite, an ending way to write something that doesn't end. Okay, that's what that notation means. So let me just show you some of those in a second. So like 1.7 repeating really means 1 point, okay. 7, 7, 7, 7, 7 forever, okay. 2.86 and the bar's over two numbers. 8, 6, 8, 6, 8, 6, 8, 6. You can have it over as many numbers as you want, not as you want. I mean, you know, numbers exist like that. Whoa.
Oh, no.
You're writing all of this down, right? When I collect your notebooks, I'm gonna see all of this. Okay, so that's what a repeating decimal does. The numbers you have been working with, well, I'm gonna always save that for my words when I write it. That's just called a repeating decimal, okay? So you never had repeating decimals. Okay. I'm gonna write some stuff for you. Which color is easiest to see? Let's just go with white.